What we got here is a military supply plane, and it is dropping a box of stuff from a great height, and it's got to reach the ground safely. So let's follow the path of this box, and specifically the forces on this box as it drops. And let's just look at the vertical motion to make things simpler. We can ignore that it's going like over 100 miles an hour horizontally to start out. But we know that there's the horizontal and vertical velocity components are separate and don't have any effect on each other. So when this box drops, it's going at a zero velocity downward, well, zero upward or downward, it's just not moving vertically until gravity gets a hold of it, and then it's the next instant it is starting to move at somewhat of a velocity downward, and that's because there's this gravitational force that's equal to the mass of the box times the acceleration of gravity. That force is always acting on it so long as it's on Earth. So after maybe 2 seconds, that force has accelerated the box to a high enough velocity that it's starting to encounter some air resistance. And that is providing a force, crashing into all those air molecules is providing a force back upwards on the box. But that force at this point is small compared to the gravitational force, such that when we add these two vectors together, the net force it looks almost like the gravitational force, but it's just a little shorter. But then as that box falls for another couple seconds, it gets even faster, and the wind is just whistling by it, and the wind is pushing a lot harder, so that the force due to air resistance is now almost as hard as almost as great in magnitude as the gravitational force pulling it down. But still, the net force is downward, but it's a very small net force. But still, our crate is accelerating downward, just not as fast a rate of acceleration as it was before. But even though the acceleration is small, the velocity is getting very large, so it is going very fast. So after it continues to accelerate a little more, it gets to that terminal velocity, which is the fastest speed that it will reach as it's falling. And it won't reach a faster speed because at this point the force from the air resistance is equal in magnitude to the force of gravity that's pulling down on the box. So those two forces cancel each other out. The net force on the box is zero, and therefore the acceleration is zero. It's not going to get any faster. It has reached its terminal velocity, and it would just stay that way. Well, advanced note, as it drops, the altitude gets lower and the atmosphere gets a little bit thicker, so terminal velocity would probably actually slow down as you get closer to the Earth's surface. But anyway, what we're going to do here, instead of just letting it fall at terminal velocity, is we're going to deploy a parachute. So, the parachute comes out, and I tell you what, that's going to significantly increase the force of drag from the air. So all the air just goes into the parachute, and suddenly the air resistance force is very high, and the gravitational force is the same old mg vector. And once that parachute is up, the force from the air resistance greatly overwhelms the gravitational force, and the net force is up, which means that the acceleration is up. So we can say it's decelerating because the acceleration is in the opposite direction to the direction of motion. And so, I mean, obviously this crate's going to slow down a lot once that parachute is up. But this is why, because there's a net force up on it. And after it slows down for a while, the drag force decreases because the wind is whistling by slower. And it'll get to a point where the drag force is decreased back down to be the same magnitude as the gravitational force. And this would be again, we'd have a net force of 0 because those two vectors cancel. Acceleration would be 0. And the package with the parachute would have reached its terminal velocity. So generally, the fluffier and less dense something is, the slower the terminal velocity it'll have. I mean, you drop like a feather and it almost instantly reaches terminal velocity.